Hello everyone, this is a problem video for chapter 1. I've had to redo it because I thought I'd only do some of my problems, but the way this is going, I do all of my problems on video. So, problem 4, chapter 1. Identify the following measurement of length. Identify each of the following as measurements of length, area, volume, mass, density, time, or temperature. A. 25 picoseconds. Okay, so with the Standard International System, the SI system, there are 7 base units, and second is the base unit for time, so time is a base unit. There is a prefix pico, meaning trillionth, so a fractional value, a trillionth. That's a ridiculously small fraction of a second. And you put the two together, 25 picoseconds, and you've got this really small fraction, really small fraction of a second. So for every 1 second, you've got 10 to the 12 picoseconds. So picosecond, obviously, is a measure of time. B, 374.2 milligrams. Now it seems weird. You figure gram would be a base unit for mass, but it's not. The base unit is kilogram. A kilogram is a 1,000-gram block, so there are 10 to the 3 grams for every 1 kilogram. If we're putting milli in front of gram, we're talking 1,000th of a gram. So for every 1 gram, you've got 1,000 milligrams. So milligram is a measurement of mass, a small fraction of a gram, 1,000th of a gram. C, 77K. K is for Kelvin. Kelvin is the base unit for temperature. So there's the Kelvin scale and the Celsius scale. We'll talk about that in a minute. So it depends where you start. D, 10,000 square kilometers. All right, so square kilometer. This brings up what's called a derived unit. A derived unit is when you take 2 or more base units and put them together to come up with a new unit. So if I multiply length by width, kilometer by kilometer, I get kilometer squared. Kilometer squared is the derived unit for area. E is micrometer. Micro is a millionth, so micrometer is a measurement of length. Nanometer squared is a unit for area. And then we get to 78 degrees Celsius. So this brings up the other scale we use with temperature. Temperature is about how fast particles are moving, and this can be very important to us in chemistry, because the way we visualize chemistry happening is particles colliding. So the more motion they have, right, the harder they hit, the more likely they are to react. So when you talk about the Celsius scale and the Kelvin scale, it's about where you start. With the Celsius scale, you're starting based off of water, right? Water freezes at 0 degrees Celsius. With Kelvin, you're starting where there is no molecular motion. So whereas you have negative values for the Celsius scale, right, going all the way down to minus 273 degrees Celsius, 273 minus 273 degrees Celsius, that's where there is no molecular motion. So where there are no motion in the particles, and that's 0 Kelvin. That's absolute 0. So Kelvin is an absolute scale. It's very important in chemistry. So we start with either you're moving or you're not. So if you're not moving, you're at 0 Kelvin. So if you want to convert from degrees Celsius to Kelvin, you just add 273 to whatever your degree Celsius is, and that puts it in Kelvin for you. Grams per cubic centimeter, right? 2.56 grams per cubic centimeter. This is another important derived unit. This is the derived unit for density. So mass, as we just talked about, right, is how much we measure it by how much gravitational pull here on Earth pulls on it. So the more matter you have, the more Earth pulls on it, and the more mass you have. So if we have these certain number of kernels, say, just generic, we weigh them on the scale. It's 28.156 grams. That's its mass. We take those kernels and we put them in a graduated cylinder with an initial volume. The difference between where the volume started and where the volume ended is what the volume of those kernels were. This is called the displacement method for measuring volume. Difference between 10 and 21 is 11 milliliters. So the volume of my 16 kernels is 11 milliliters. So when I take milliliters and divide it into grams, I get grams per milliliter, or grams per cubic centimeter. Cubic centimeter and milliliter are synonymous. They mean the same thing, right? So, oops, I went too fast. So volume, right? Volume, cubic centimeter, a derived unit. Length times width times height. So centimeter times centimeter times centimeter gives me cubic centimeter. So this is where we get the derived unit for volume. Divide that into grams and you get the ratio grams per cubic centimeter.